today's lesson on 1.3, we're going to talk about measuring line segments. This lesson can be quite challenging to wrap our head around, so I'll go slow and try my best to explain our two different examples of how to do this, and make sure you pause the video and back things up if you feel like you don't understand something. So the first thing we need to do before we figure out how to find the length of a line segment using some of the tools we learned in lessons 1.1 and 1.2 with perfect squares is we need to understand some basics about finding the area of different shapes. So this investigate is going to do just that. So A asks us to find the side length of each shape. Well, if I look at my square, it's got a side length of 5 all the way around it, okay? So the square has side length of 5, okay? If we look at the triangle on the right, well, it also has some side lengths of 5 for these two sides. And this side over here, it's on an angle, but if we take a look, these angles go from one corner of the square to the other corner. It can be kind of challenging to measure because we can't actually pull out a ruler on the screen. So I'm just going to put a question mark right now, and we're going to say that the side lengths of our triangle are 5 on two sides, just like so, okay? So we know two sides of our triangle for sure. We're just going to scroll down here and we're going to try and figure out part B. Part B says find the area of each shape. Well, if we think about the area of a square, well, we did this in 1.2, but the area of our square is simply going to be the length of the square squared, okay? So for our question, that's going to be 5 was our length, and we're just going to square that number, which is the same as squaring a number is multiplying it by itself. So 5 times 5 equals 25, okay? The next thing we need to do is find the area of our triangle. Well, the area of our triangle would simply be, if you remember from grade 7 math or grade 6 math or any of your other math classes, is base times height divided by 2. So to solve that, I'm going to say my base is 5 and my height is 5, and I'm going to then divide by 2. So 5 times 5 divided by 2 would equal 25 divided by 2. And if I take 25 and divide it by 2, all I'm doing is cutting it in half, which would give me 12.5. Now, there's one thing I'm missing in my final answer from both of these questions. Since I found the area, I need to list this as a unit squared. Now, I don't know how big these units are, and I know I don't want to write 25 squared because that's telling me to go 25 times 25. So I'm just going to say 25 units squared and 12.5 units squared. All right. So if we look at our connect section here, it just tells us that to find the area of different shapes, we use certain formulas. So area is always equal to A, length is always equal to L, okay? The base we always just write as a B, and the height as an H. The area of a square is area equals length squared, and the side length of a square is the length, we could go equals area square rooted, okay? So that's just doing the opposite operation. If we look at our example above, we know that we had a square that had an inside area of 25. Well, all this part is telling me is I can go the square root of the area, which is 25. Well, the square root of 25 equals 5. So that then tells me the length would be 5. And the area of a triangle is area equals base times height divided by 2. We just did an example of that above. So just below that, it says we can calculate the length of any line segment on a grid by thinking of it as the side length of a square. So there are two ways to draw the square. So we can go 1 by drawing inside or 2 by drawing outside of the square. For our first example today, we're going to look at drawing inside the square. So remember, as we go through this, make sure to pause the video and go back if you are lost or confused. So we're going to look at drawing inside of the square, okay? So we are given line segment PQ. So I'm just going to highlight that here on the screen. So this is our line segment right here, and we're going to label it PQ, just so we know what we're talking about. Step 1 says you use a ruler and a protractor to construct a perfect square on line segment PQ. So here was our original line segment PQ, and they've gone ahead and done this for us, but they used a ruler and protractor to turn this into a perfect square. The ruler tells you how long each line is, and the protractor helps us make sure we have 90-degree corners. And if we've done this correctly, it should line up pretty perfectly on our grid. Okay? The length of the line segment is the square root of the area. We know that because we just talked about that above. Okay? Step 2 says, cut the square into 4 congruent triangles and a smaller square. So that's been done for us here as well. So if we take a look, all that is our white lines, which I'm going to highlight in blue here. They've cut this square into 4 triangles, just like so, and left us with one smaller square in the middle. Okay? So now, if I look at that, I can see that I've got some shapes that I recognize, and I can find the base and the height of those triangles and the side lengths of the square in the middle. So first I'm going to try and find out the area of the triangle. So the area of a triangle we know is base times height divided by 2. So I'm going to write that out here, base times height divided by 2. I know if I look at these triangles, we can say I'm going to focus on this top triangle right here to start. It has a base of 1, 2, 3, 4 units, and a height of 2 units. We've got 1, 2. So it's got a height of 2 units. So we can say the area for this would be 4 times 2 divided by 2. Well, 4 times 2 is 8. Divided by 2 would give me an area of 4 units squared. Okay? So each of these triangles, which we now have 1, 2, 3, 4, they're all congruent, they're all the same, and they all have an area of 4 units squared. So let's scroll a little bit. Step 4 asks us to find the area of all 4 triangles. Well, if I'm going to find the area of all 4 triangles, all I need to do is take the area of one triangle, which was 4 units, and multiply it by a total of 4 triangles. If we do that, we'll find out that there's a total of 16 units squared in our blue triangle. Okay? Step 5, we're going to leave that as is for now. Step 5 says find the area of the small square in the middle. Well, if we look at that small square, it's got side lengths of 2. Okay? So the area of a square is length squared. So all I need to do is area equals the length is 2, 2 squared, which then would equal 2 times 2 is 4 units squared. And we can visualize that pretty easily when we look at that square because it has 1, 2, 3, 4 squares inside of it. Step 6, find the area of the triangles and the small square. Well, the triangles were 16 units squared, and the small square was 4 units squared. Okay. Step 7 says find the length of the square. So, well, let's take a look at how to do that. So to find the total interior area of the square we drew in the very beginning, all I need to do is add my 16 and my 4 together. Okay? So 16 plus 4 tells me I have a total area of 20 units squared inside of my square that I created with the line segment PQ. Then all I need to do is square root that number, and it's going to tell me the side length. So for this question, we're going to say that the length is equal to the square root of the area. Well, this question gives us the square root of 20 as our answer. Now, hopefully you'll notice that that's not a perfect square, and for grade 8 math, we do not need to find the decimal version of this. We can simply leave our final answer as length equals the square root of 20. So it's not a perfect square because it's not 25, which would be the perfect square just above it, and it's not 16, which would be the perfect square just below it. So we'll leave our final answer as length equals the square root of 20. And we'll fill in some notes that say since 20 is not a square number, we cannot write the square root of 20 as a whole number. We know that's going to give us a decimal somewhere in between 4 and 5, and we will learn more about that in the next lesson.